Okay, this video we are going to work on simplifying cube roots. So this is very similar to simplifying square roots or radicals, but the difference is that we're going to be dealing with cube roots instead. So just a refresher that you can identify a cube root. We have the radical sign, but there is a little 3 in the corner. Now, you don't want to get that confused with a 3 being multiplied. So this is a little 3 that's kind of right in that little check corner mark of the radical sign. So if you keep in mind what happens with square roots, then cube roots are pretty easy because the only thing that's different is that we need 3 of a kind in order to come out of the radical. So here we go. Let's start off with example 1. So let's say we want the cube root of 24. All right, so what we're going to do is same process. So let's break this down. So 3 times 8, and then 8 would be 4 times 2, and then 4 would be 2 times 2. So I know that this is 2 times 2 times 2 times 3. And since I want the cube root, I need to have 3 of a kind in order to come out in the front. So since I have 3 2's, I can have 2, and then that leaves the cube root of 3 inside. So very simple, similar to how square roots work, except we have to have 3 of a kind in order to come out in front. All right, so example 2. So let's say we had the cube root of 32. All right, so we're gonna start breaking this down. We could say 4 and 8. That's gonna be 2 and 2. This is gonna be 4 and 2. And that's gonna be 2 and 2. So I know that 32 is the same as 2 to the 5th. So 3 of them can come on out. So I know I'm going to have a 2 on the outside, and I don't have enough to make a group of 3. So that's going to stay inside, and anything gets multiplied back together. So again, same idea, except we're looking for the cube roots. So thinking about what a shortcut could be is that if I, let's see, for example 3, let's see. Let's say I want the cube root of 40. Okay, I know that 2 to the 3rd equals 8. So that tells me that the cube root of 8 would equal 2. So I can be a little bit smarter by thinking that 40 is 8 times 5. And then this right here lets me bring a 2 on the outside. So this would be 2 times the cube root of 5. So this time, instead of looking for perfect squares, we're really looking for perfect cubes. All right, last thing I want to mention is what happens with our variables, which again is very similar to what happens when we're simplifying square roots. And that is that we need 3 of a kind in order to come out. So let's just say we have 3 and then the cube root of, let's say we have 64 A6B7. Let's try that. All right, so first thing I'm going to do is work on 64. So I know that can be 8 times 8. So at this point, I know that the cube root of 8 can come out as a 2, and then this cube root of 8 can come out as a 2. But just in case, we could even just say, I know that 8 is 2 times 2 times 2. And I know that 8 is 2 times 2 times 2. So we have the cube root right there. This can come out as a 2. This one can come out as a 2. And I already had a 3 out there. All right, so now looking at the variables, this time I have to make groups of 3. So if I have a to the 6th, I want to ask myself, how many groups of 3 can I make? And I can make 2 groups of 3 with no leftovers. When I look at b to the 7th, I want to think of how many groups of 3 can I make? I can make 2 groups of 3 with 1 b left over. And let's just say that we had a c squared here. So I'm going to say, how many groups of 3 can I make with c squared? I can't make any, so that means that the c squared stays inside the cube root, and I don't have a c on the outside. And then anything that's left gets multiplied together. So my final answer for this would be 12 a squared b squared times the cube root of bc squared. And that is going to be my final answer. So again, it's very similar to simplifying square roots, except when we simplify cube roots, we're looking for groups of 3 in order to come outside of the radical sign.